Hi everybody, welcome to my presentation. My name is Austin. I chose to work with Optuna and I'm using it with LSTM to predict stock price movement. So Optuna helps you optimize machine learning models by trying out different hyperparameter combinations. And I'll just use this basic example here to show you how it works. In this example, we are suggesting different variables for x and y um, between -10 and 10, and then we are trying to minimize the whatever this expression returns, just like we try to minimize whatever loss we have with the machine learning model. And so Optuna will go through 100 trials, and it will try different combinations of x and y to return the smallest number. And so we see here that trial 82 in the middle here performed the best with 4.96 as x and y as 9. And that returned 0.001 in that expression. And we'll see how this looks in a machine learning model a little bit later. Just a quick overview of my program. I'm using Yahoo Finance to download data, and I'm engineering some features. And then we're using Keras time series data set from Array to use as data sets. And then we're using a few functions to create LSTM models, and then we're back testing them after we create a study. So here we are downloading the data. Exploring the data here. Tesla had quite a bull run in this segment of data. Here we are creating data sets, which is pretty standard, we've done before. And here's where we start actually using Optuna, or start setting it up. We have a function that builds an LSTM model, and it has these different variables: optimizer name, LSTM units, and dropout rate. So Optuna will call this function and plug in different suggestions we have to return a loss. So here we have the actual suggestions, and we see have these different hyperparameters I'm suggesting, and we can expand this or use less if we want, and we call that function to build an LSTM model with different combinations of these hyperparameters, and we're returning the loss. And the way this program is set up is just to figure out what is the best combination of parameters, not actually to return the best model. And so we use a callback to print out everything. And once this is what the printouts look like, very similar to the basic example. And then after 20 trials, which took about 30 minutes on my M2 Air, we find that we get this is the optimal parameters with this loss. And so we're able to call upon that best trial object and use its parameters within the build LSTM model function we defined. And then we have our most optimal model. And so here's just a plot actual versus predicted. We'll see I used a non-Optuna model. It was actually the similar model to the one we did for homework 8, I believe, using LSTM for stock price movement. Optuna did a lot better. You can see on this graph we're targeting daily returns, just to give you an idea what those numbers mean. And here are the metrics. You'll see yes, Optuna had significant, much less loss. And the back testing is basically if it's the absolute value is less than 0.01, we just have a hold strategy. Otherwise, if it's greater than 0.01, we're going to enter into a position at open and then close it at close. So that's why we have this actual return, and we are going to add that to our returns column. And then if we get a -1 as a signal, if it's we're predicting a less than a 0.01% drop in stock, we'll actually short that, so we'll just take the negative of that. And so here you'll have, you see we have a printout of just how it performed in the back test. If we had a hold strategy where we just opened a position at first open and then closed it at the last day, we'd have made only $15, whereas we made about $91 Optuna trading, and we lost a little bit of money on the non-Optuna signal trading. But I've had tons of different results. It's definitely not consistent, so it's not really ready to make you rich quite yet. Anyways, thank you very much, and I hope you enjoy my presentation.